Imagine. It's a quiet night. The sky is clear, the air still. Somewhere, far above you, a rock, older than Earth itself, cuts through the darkness. It's been drifting for billions of years, and tonight, it's coming home. At first, you wouldn't notice anything. Maybe a faint streak of light, a glowing tail across the horizon. Beautiful, harmless, until it isn't. Because when a meteorite falls, it's not just a rock. It's a message from the universe. And depending on its size, that message can mean the end of everything. Let's start small. Every single day, Earth is hit by over 100 tons of space debris. Dust, pebbles, tiny fragments of rock. Most burn up high in the atmosphere, becoming the shooting stars we make wishes upon. But sometimes, one of them is big enough to survive the fall. When a meteor enters Earth's atmosphere, it's moving faster than anything we can imagine, up to 70 kilometers per second. That's 60 times faster than a bullet. The air in front of it can't get out of the way fast enough, so it compresses, heats up, and turns into plasma. The surface of the meteorite starts to vaporize, glowing white-hot. The sky tears open with fire. If it's small, a few meters across, it'll explode mid-air, like the one over Chelyabinsk in 2013. It released 30 times more energy than the Hiroshima bomb. Thousands of windows shattered, people were thrown off their feet, but the rock never even touched the ground. Now, imagine it didn't break apart. Imagine it hit. A 10-meter wide meteorite would strike with the power of a small nuclear bomb. 100 meters? You're looking at a city destroyer. It wouldn't just flatten buildings. It would create a shockwave, hurricane-force winds, and firestorms. At that size, impact is almost impossible to survive if you're anywhere nearby. But that's still nothing compared to what's out there. Because once every few thousand years, something much larger comes along. A kilometer-wide asteroid. Big enough to end civilizations. The last time that happened was 66 million years ago, the day the dinosaurs vanished. Scientists call it the Chicxulub impact. A rock 12 kilometers wide, traveling at 60,000 kilometers per hour, slammed into what is now Mexico. The energy released was equal to 10 billion atomic bombs. The ground liquefied, the sky caught fire, and within hours everything within 1,000 kilometers was vaporized. The Earth itself rang like a bell. A wall of debris shot into space and fell back as molten rain. Dust and ash blocked out the sun for years. Temperatures dropped, plants died, animals starved. The planet went dark. And for 70% of life on Earth, that was the end. Now imagine something like that. Today, it starts with a flash. Satellites detect a heat signature moving faster than anything man-made. Observatories confirm it's coming straight for us. Governments scramble, scientists calculate trajectories, news spreads like wildfire. And then, silence. There's nothing anyone can do. The rock is too big, moving too fast, and we found it too late. Hours later, day turns to night. The horizon glows like dawn, but the light is wrong. It's too bright, too sharp. You look up and see a second sun, falling. When it hits, the world ends in an instant. The shockwave circles the planet. Earthquakes ripple through continents. Oceans rise into walls of vapor and fire. Cities thousands of kilometers away are flattened by hurricane winds. In the darkness that follows, ash rains for months. Sunlight can't reach the surface. Crops fail, temperatures plummet. The world freezes, starves, and slowly dies. But here's the strange part. Even after all that, life would return. It always does. After the dinosaurs vanished, mammals, tiny, fragile, warm-blooded creatures, survived. They evolved, adapted, and eventually became us. In a way, you could say, we are the children of an ancient impact. Without that meteor, humans might never have existed at all. So what if it happened again? Would we go extinct? Or evolve once more? Today, we're no longer helpless. We have telescopes that can track asteroids years before they reach us. NASA's DART mission proved that we can deflect an asteroid, at least a small one, by hitting it with a kinetic impactor. It's a start. But against something massive, we're still not ready. If a 5-kilometer asteroid were discovered on a collision course with Earth, we'd need decades of preparation to stop it. Deflection, nuclear devices, gravity tractors, all possible, but all limited by time. And time is the one thing the universe never gives freely. Still, the odds are in our favor. Most large asteroids orbit predictably, and none are known to threaten us in the near future. But the smaller ones, the city killers, the Chelyabinsk types, they're harder to spot. They come from blind angles, hidden by sunlight or space debris. We might not see them until it's too late. So the next bright flash in the night sky could be harmless. Or it could be the start of something our species has never witnessed before. If a meteorite falls to Earth, it's a reminder, a warning written in fire. The universe doesn't care who we are or what we've built. It moves on scales beyond imagination, indifferent, eternal. We exist in a brief, quiet moment between catastrophes. And yet, maybe that's what makes life so precious. Because every sunrise, every breath, every heartbeat exists in defiance of extinction. And somewhere, drifting in the dark, another rock is already on its way. The question isn't if it will fall, it's when.